we've got A and B, so we've got a graph here. We don't know what the graph is, but for 9, we know that here's f of x. So the A and the B are going to be, A is 0.5 and B is going to be 2, right? So 0.5 over here, 2 over here. Okay. What we want to do, first of all, is find the equation of the secant line AB. So I guess what we have to do is find the slope of the line, AB, whatever the slope is, and then use 2 points to find the line, or at least 1 point, right? Point slope form to write an equation for the line. Okay, so if I find out what f of 0.5 is, that's going to be 0.5 plus 1 over 0.5, which is 1 over 0.5 is going to be 2. And then plus 0.5, so 2.5, let's say, 2.5. All right. Now, f of 2 is going to be 2 plus 1 over 2, which is going to be also 2.5. So f of 2 is also 2.5, okay? Now, so that means that here's 2.5 on the graph, here's 1 point, and here's the other point. So they're both at the exact same y values, so the slope of the line connecting the two will be 0. All right? So if you see this, you could say, okay, the slope of the line, m equals 0. And if you don't quite see that the slope of this line is 0, then consider this. M is y2 minus y1 over x2 minus x1. That's the slope of the line connecting any 2 points. And so y2 is 2.5 minus y1 is 2.5. And then we have, it doesn't really matter, really. We have 2 minus 0.5. So that equals 0. Good with that? Okay. So now what we need to do is we need to pick basically 1 point, and we'll do y minus y1 equals m times x minus x1. And y minus, let's see, what's one of the points? Well, let's do 2.5 equals 0 times x minus 0.5. So that's the x value from here and the y value from here. And of course, 0 times this is just going to be 0. So we have y equals 2.5. That's the equation of your line. And as they show it here in the textbook, it's y equals 5 over 2. Same as 2.5. Okay, good. Are we good with that so far? Any questions about that first part? Let me zoom out. Yeah, is your hand up there?
I was going to say, do you even need to do that? Like, if you just know it's a straight line across.
Yeah. If you see the y values are the same, you're trying to find the slope there, you just know the slope is 0. So you could go right to here. I just showed you this part in the black, just in case you wanted to make sure you did the slope properly, or whatever. But yeah, you could just go right to slope is 0. And then if slope is 0, then it's just a horizontal line, y equals 2.5. You don't really need to do this part either. You would need to communicate though. Like, I mean, you want to show that you know what you're doing. You don't probably want to go from, here, just the, there, right down to y equals 2.5 without any supporting kind of
Is your
pathway.
graph support enough?
If you draw the graph, you could say m equals 0. That's a horizontal line, therefore y equals 2.5. Yep, that's fine. What about this, a tangent line of f? So write an equation for a tangent line to f on the interval that's parallel to AB. So looks like any equation that has that's parallel to a tangent line. So the tangent line is going to be y equals 0 something, right? Or m equals 0. So any parallel line would be any other, looks like it'd be any other horizontal line that you can name. So you can do anything. An equation for a tangent line to f that is parallel to AB. That is parallel to AB.
So is it just, like, if that was an equation, would that just be 2.5 plus x?
A tangent line to f. Okay, hang on for a second. Okay. So a tangent line to f. All right. I reread that here. So what we have to do is consider this as f. So a tangent line is going to be the derivative of f, right? that has a slope of 0. So you find the derivative of f, and then you figure out where that has a slope of 0. So derivative of f, let it equal to 0, and then find that x point, I guess. So an equation for a tangent line to f, so here again, here's f for 9, a tangent line to f. Because we don't know if, again, the graph doesn't necessarily, it's not this black line. The graph could go like this, right? It could be like totally crazy. So we need to find a tangent line that's parallel to this AB line. Now, if you want to use a calculator to find out what your graph looks like, that's fine. You can do that. So if we graphed f of x here, yeah, just put it up there somewhere, thanks. And then 1.6, I guess. So we'll go on, and we'll go clear, and we'll go y equals, clear that. So x plus, I'll do bracket 1 divided by x. And we'll graph that. So here's what it looks like, just like this. So the graph kind of looks like this. And we need to find out where this has a derivative of 0. So we're looking for kind of this point, whatever that is. And could we go over here too? I guess we could, hey? We could go kind of down here as well and look for a point down here. It does say that it should be between 0.5 and 2 though. So I guess we will ignore this kind of part of the graph. So we'll find the derivative of f of x, and we'll let it equal 0 and solve for the x.
Why wouldn't we use this?
Well, you are kind of using that formula. You are using the MVT formula, but we already know that the secant line connecting A and B there, we already know that that's a horizontal line. So the MVT formula on the right, if, sorry, let me just get to it quick here. Yeah. These are notes not from yesterday. Rolle's theorem, I don't want Rolle's theorem. I don't want that either, give me a second. Oh yeah, so right here. So for the mean value theorem, like this part right here, that is the secant line connecting kind of A and B, whatever. We already know that that's a horizontal line. So this whole thing is equal to 0. And your notes, let me just see where your notes went to here. Yeah, so you're talking about this right here.
Yeah.
So we already know that this side is 0, because we calculated that as being 0, right? So that's 0. So I just need to find the derivative of the function and let that equal to 0, and then solve for the x value. That will be the c. That'll be the c we're looking for. Okay, so, oops. All right, so this is a bit of a mess here. I'm going to get rid of some of this here. And I am going to find the derivative of this function and let it equal 0. Solve for x. So f prime of x equals, the derivative of x is just 1. If you do the quotient rule on 1 over x, you get minus 1 over x squared. Should be derivative of the top times the bottom minus the top times the derivative of the bottom. That's minus 1. And all over the bottom squared, x squared. So now we just let this equal 0. Equal 0. And there I've got my f prime of c equal f of b minus f of a all over b minus a. So that's what we have now. That's what we have. So 1 over x squared equals negative 1. There, okay, so 1 equals x squared. 1 over x squared. So x is 1. So if x is 1 here, that's what I get there when we solve.
Wait, why just divide it by 1?
Well, 1 minus 1 over 1 would give us 0, so x is 1. So this is the x value. So what is the, I guess what we're looking, so we know that there's a horizontal tangent line at x equals 1. So what I need to do now is find out what the y value is here, you see? And then that will be the equation of the tangent line. So what we're solving for here is x, you see? And that's this value right here. So I need to put 1 in for x here to find out what, really I'm looking for f of 1 now. So that's 1 plus 1 over 1 is 2. So f of 1 is 2. The equation of the tangent line here will be y equals 2. Is the equation of the tangent.
Where did your squared go from 1 over 1 equals x?
I took the square root. Square root of 1 is 1.
Seems very silly that I didn't do that.
Okay, does that help? Questions on that? All right, these aren't easy questions. These aren't easy questions. They definitely take some thought.